Hello everyone! Welcome back to the 3D modeling lessons. These practical lessons for students of architecture and design specialties. And today we are going to continue to study how to use splines to create 3D models. So on this lesson we'll study spline modeling. We'll try on practice to do exercise to create still nature with different objects like fruits and vase, and we'll introduce to loft modeling. And today we following next aims. First, we'll do exercise how to create still nature objects. Second, to create still nature objects, we should understand how to combine different modifiers. Like for example, to create an apple, we'll do one model base with spline rotation, but to do apples different with shapes, it's need to do combination with another modifier's commands. Third, we'll have acquaintance to loft modeling. It means that if you understand the first principles of how to use loft modeling, you can create many variations of 3D objects. This picture shows a rendering of a scene using spline modeling and modifiers. If you look closely at the scene, you can come to the conclusion that all objects are made on the basis of primitives or using standard modifiers, and are not very difficult to execute. The central place of the whole composition is occupied by a bronze vase. We will start our modeling with it. You probably already know that the easiest way to build objects with an axis of rotation is using the lathe modifier. Our fruit vase will be no exception. And let's start modeling by building a spline of its contour. To do this, follow the steps. First, select the Create, Shapes, Line command from the main menu, and in the front viewport, start drawing a spline of the vase shape as shown in figure. Earlier in the spline modeling exercises, we looked at how splines are constructed and how to edit them. So here is advice for you. Start building the profile shape for the revolved body from a vertical line, thus defining the start and end points of the spline, gradually adding new vertex with Refine command, and editing their position in space. In addition, you can build a contour by sequential creation of vertex from start to finish. In this case, you need to ensure that the first and last vertex of the spline are on the axis of rotation, for which use snaps to the mesh. In the front projection window, it is necessary to arrange points in such a way as to give the desired shape to the created vase. Use the Modify panel to select the vertex. Also, set the desired vertex type. This can be done from the submenu by left-clicking on the vertex. It is especially convenient to use the Bezier corner vertex type, which has two direction vectors that are independent of each other. so you can give for outline a clearer path. Second step. Apply the lace modifier, which will do rotation to the constructed spline by executing the modifiers patch spline editing lace command from the main menu. In the Align group of the parameters rollout, click the Min button to set the axis of rotation to the left side of the object. It is possible that you will need to select a different type of alignment. It all depends on how the contour curve is constructed. Probably you will need to open Lace modifier in the stack and pick the axis. After, in Front Viewport, just move the axis of modifier inside. So you will see a right form of rotation around central line of contour. Step 4. In the segments counter of the parameters rollout, set a value from 30 to 40 in order to avoid unevenness at the edges of the constructed objects. Step 5. If necessary, go through the stack to the level of curve editing and having activated the Show End Result On/Off toggle, change the shape of the curve so as to obtain an acceptable result. So now the vase is modeled. It's time to fill it with fruits. Now let's add apples to this composition. We'll create an apple in same way what we did with vase. It need to apply for contour of apple lace modifier. Once we'll create 3D model of apple, we can combine some other modifiers for duplicate of first model. So it will give us variety of different shapes of many apples. To build a model, follow the steps. First, in the front viewport, draw an apple-shaped spline, using the method you already know as shown in the example. Second, apply the lace modifier to the contour spline by executing the modifier patch spline editing lace command from the main menu. 3. In the parameters rollout, set the values similar to those used to build the vase. 4. If necessary, return to the spline vertex editing level and refine the profile shape. 5. Apply a noise modifier to the object to create irregularities on the surface of the model, as in the example, for which from the list of modifiers on the Modify tab of the command bar, select the Noise line. 6. In the parameters rollout of the modifier, set the scale counter to 100 and the x, y, and z values of the straight group to 175, 140, and 135 respectively. So now it remains to add a small root to the apple, which we're going to do now. For this, you have to create a parametric object, cylinder, for which we will use create standard primitives cylinder command from the main menu, and in the top viewport create a cylinder at the point where the spine is attached to the apple. In the front viewport, using the Select and Move tool, move the constructed objects in the vertical plane so that it takes its place in the recess of the apple. If necessary, refine the radius and height of the cylinder in the parameters rollout. They should be in the proportion to size of the apple. In parameters rollout, change the height segment's value to 10. This will give the objects an even bend. Apply the taper modifier to the constructed cylinder by selecting it from the modifier list of the Modify tab of the command bar. Finish building the spine by applying the Bend modifier, added to the modifier stack in the same way as the Taper modifier, as shown in the example. Thus we have built a model of an apple, but creating a still life, one model will not be enough. With the FFD box Free-Form Deformers modifier, which is FFD container rectangular, you can easily fix this by creating an apple of a different shape. Let's do the following. Create a copy of the apple, model along with the spline. To do this, select both objects and hold down the Shift key, and move the object to the side in the top viewport. In the process of copying, in the Clone Options dialog box that appears, select Copy. Select the apple model and apply the FFD box modifier, which is rectangular, for which select the main menu command, Modifier, Free-Form Deformers, FFD box modifier, Arbitrary deformation, FFD container rectangular. In the Dimensions group of the FFD parameters rollout, click the Set Number of Points and the Set FFD Dimensions dialog box. In the Modifier stack window, go to the Set Volume sub-object editing level, as shown in the example, and using the Select and Uniform Scale tool, adjust the shape of the FFD container so that it generally repeats apple shape. In the Modifier Stack window, go to the Control Point sub-objects editing level and select 4 vertices in the top row that are equidistant from the center in one row. Using the Select and Move tool, move the selected points slightly upward, forming an apple model in the spine area. Select the same 4 points of the FFD container in the bottom row and move them down a little to get the final apple shape. Now you can group the apple and the root in the first and second versions in order to be able to manipulate the group and make several copies for a still life. Having made 2 or 3 copies of the object, you can modify the shape of these copies by returning to the parameters of the noise of FFD box modifier and making the appropriate changes there. The next step is to simulate the pear. The process of building this model is exactly the same as for an apple. We start by building the contour spline, then apply the lace modifier, rotation, and finally refine the model shape using the noise modifier or FFD parameters. Next, let's consider the process of modeling a bunch of grapes. In fact, we only need to create a stem and 1 berry, by copying which we will get a whole bunch. To build a grape model, let's follow next steps. In the top viewport, we will create a sphere by selecting Create Standard Primitives Sphere from the main menu. Since when constructed splines for a vase, apple and pear, we didn't take into account the real sizes of those objects, but only focused on their proportions. Then in the case of grapes, it is necessary to do the same. In size, the sphere should correspond to the size of the grape berry and be comparable to the size of previously built objects. Using the Select and Uniform Scale tool, scale the sphere vertically so that it becomes elongated. If desired, it can be refined using additional surfaces modifiers. So now to create the branch for each grape, we'll use Loft Modeling principles, and later we'll introduce more closer what is loft and how to use it. In the front viewport, draw a spline in the manner known to you, which will serve as the shape of the path of the loft object for the tail located in the upper part of the berry. In the top viewport, create a circle, which will be the cross-sectional shape for which use the Create Shapes Circle command from the main menu. Select the spline path if it is not selected and execute the command Create Compound Loft. In the creation method rollout, click on the Get Shape button and in one of the projection windows, point to a circle. Click the Modify tab of the command bar and in the Deformations rollout, click the Scale button to open the Scale Deformations dialog box. In the Curve Editing window, change the shape of the spline so that you get the tail of the desired shape. As with the apple and pear, group the objects and then create about 20-25 copies of the model. Distribute the created objects in space so that you get a bunch of grapes lying on a platter. Before to start create banana, we'll introduce with understanding what is loft and parameters of loft command. The loft tool is used to create 3D geometry or loft objects from 2D shapes. For creating a loft object, you need to create a path and shape spline in the viewport. To create a loft object, choose Create Shapes Splines in the command panel. Next, create a spline that you need to loft and create another spline to be used as a path. Refer to the example. Select the spline in the viewport that you want to loft along the path. Choose the Loft tool from the Object Type rollout in the Compound Objects. The Name and Color Creation Method, Surface Parameters, Path Parameters, and Skin Parameters rollouts will be displayed. Now choose the Get Path button in the Creation Method rollout and move the cursor of the path spline in the viewport. The shape of the cursor will change into a selection cursor. Select the path spline. The loft object will be created along the shape of the path spline. Refer to the example. You can also create a loft object using the Get Shape button in the Creation Method rollout. To do so, first you need to select the path spline and then choose the Loft tool from the Object Type rollout in the Compound Objects. Choose the Get Shape button in the Creation Method rollout. A selection cursor will be displayed in the viewport, which will prompt you to select the shape spline. Select the shape spline, the loft objects will be created along the path. The most commonly used rollouts to modify the loft objects are discussed next. Creation Method rollout. The options in the Creation Method rollout are used to select the path spline or the shape spline in the viewports to create a loft object. If you first select the shape spline in the viewport, Then you need to choose the Get Path button in the Creation method rollout to select the path spline in the viewport, along with the shape will be extruded to create a loft object. If you first select the path spline in the viewport, then you need to choose the Get Shape button in the Creation method rollout to select the shape spline in the viewport to create a loft object along the path. Select the Copy, Instance or Move Radio button to specify the type of path or shape added to the loft object. Surface Parameters Rollout. The options in the Surface Parameters rollout are used to specify the smoothness and the mapping coordinates of the lofting surface. The areas in this rollout we will discuss next. Smoothing area. In this area, the smooth lengths and smooth widths checkboxes are selected by default. The Smooth Lengths checkbox is used to create the smoothness along the length of the path. The Smooth Width checkbox is used to create smoothness around the circumference of the path. Mapping area. The Apply Mapping checkbox in this area is used to apply the mapping coordinates to the loft objects. On selecting this checkbox, the other options in this rollout will be activated. Set the value in the length repeat spinner to specify the number of times the map will be repeated along the length of the path. Set the value in the width repeat spinner to specify the number of times the map will be repeated around the circumference of the path. Materials area. In this area, the Generate Materials IDs and Use Shape IDs checkboxes are selected by default. The Generate Materials IDs checkbox is used to create the materials IDs for the loft objects. The Use Shape IDs checkbox is used to create the material IDs from the spline material IDs. The material ID is the identification number that determines the submaterial in the multi-sub-objects material. Output area. The options in the output area are used to define the type of the loft objects to be displayed. By default, the Mesh Radio button is selected, and it is used to produce a mesh object. The Page Radio button is used to produce a page object. Path Parameters Rollout. If you use more than one shape to create a complex loft object, then the options in this rollout will be used to specify the position of multiple shapes along the path of the loft object. Set the value in the path spinner to define the distance between the multiple shapes along the path. Select the On checkbox. The Snap spinner will be activated. Set the value in the Snap spinner to define the snap increments while setting the value in the path spinner. For example, if you set the value 10 in the Snap spinner, then on setting the value in the path spinner, it will be increased in the multiples of 10. By default, the Percentage Radio button is selected. Therefore, the values in the path and snap spinners are defined as the percentage of the total path length. Select the Distance Radio button to define the values in the path and snap spinners as the distance from the first vertex of the path. To place the shapes on the path steps and vertex, select the Path Steps Radio button. Skin Parameters Rollout. This option in this rollout are used to simplify the mesh or patch object. Deformations rollout. This rollout will be available only when you choose the Modify tab in the Command panel. The options in this rollout are used to modify the loft objects to get different shapes. You can scale, twist, teeter, bevel, and feed the loft objects using the tools in this rollout. To modify a loft object, first select it in the viewport and then choose the Modify tab in the Command panel. Now expand the Deformations rollout and choose one of the tools in this rollout to modify the selected loft object. The respective deformation dialog box will be displayed. The Scale Deformation X dialog box we can see in the figure. By default, a horizontal red line is displayed in this dialog box that represents the path steps along the x-axis of the loft object. The left point on the line represents the first vertex of the path. The right point on the line represents the last vertex of the path. To modify the loft object along its x-axis, choose the Move Control Point button at the top in the dialog box. Now move the cursor over the first or the last vertex. The shape of the cursor will change. Press and hold the left mouse button on the vertex and move the cursors vertically to scale the shapes of the loft object. You can also insert more vertex in between these two vertices. To do so, choose the Insert Corner Point button on the top of the dialog box and click on the path where you want to insert the vertex. To modify the loft objects along the y-axis, choose the Display y-axis button at the top in the dialog box. The path for the y-axis will be displayed in green color. Now we will come back to the modeling of banana fruit. Here we'll use the construction of the loft objects and then editing the deformation of the scale deformations, similar to what we did for the grapes. In order to build a banana model, perform the following constructions. In the top viewport, draw a path spline which is slightly curved line. In the front viewport, create a cross-sectional shape by using the Create, Shapes, and Gone command. In the size counter of the parameters rollout, set the value to 6. Construct a loft object by selecting the path spline and executing the Create Compound Loft command from the main menu. In the Creation method rollout, click the Get Shape button and in one of the projection windows, point to the N-gon. On the Deformations rollout, click the Scale button to open the Scale Deformations dialog box. In the Curve Editing window, change the shape of the spline so that you get the shape of banana. Simultaneously with editing the spline, visually control the change in the shape of the objects in the projection windows. In order to smooth out the sharply outlined edges of the model, you need to add the Relax modifier, for which execute the command modifiers parametric deformers relax. In the parameters rollout of the relax modifier, change the relax value at iterations so that you get a little smoothing at the edges. As an independent task, build additional objects in the scene. For example, a sphere can be used to create a variety of objects. For example, orange, cherries, strawberries, and even half a lemon and kiwi. In this case, for the rendering after construction, you need to use the Select and Uniform Scale tool to compress the sphere in the vertical plane, and half of the kiwi is obtained after setting the hemisphere value of the parameters rollout to 0.5. You can see the final result of the composition with fruits on the screen. Of course, in order to achieve greater realism in the picture, it is necessary not only to be able to model, but also to know the principles of using materials and textures as well as lighting and camera settings. But all this awaits us ahead. And that concludes our lesson on still life modeling. So let's summarize what we have learned. Creation still nature objects with splines, understanding how to do combination of modifiers, and introduction to loft modeling. See you later.